Hi folks, today we're going to talk about solving systems of equations, systems of linear equations using substitution. In Algebra 2, the way that we talk about this is we really reference what you learned in Algebra 1. In Algebra 1, you solved by substitution, and that was one of the two algebraic ways that you would solve a system. And so today we're going to kind of remind you of how to do that. And all of this builds towards taking systems of equations and kind of pushing it to another level in Algebra 2. So in Kami, I'm going to use my text tool to fill in these blanks. So number one, when you're solving systems of linear equations or even equations with quadratics, and you're solving them by substitution, the first thing that you want to do is solve one equation for a variable. We'll go ahead and make that red so it stands out. So solve one equation for a variable. It doesn't matter which equation. Sometimes there's definitely an easier of the two to pick from. So solve one equation for a variable. Then you want to substitute the expression from step one into the other equation of the system. So once you solve, you're going to take what your variable equals and you're going to substitute it into the other equation. After you do that, you're going to solve for the remaining variable. At this point, you should have one variable solved for. Usually you have x and y in a system, so you'll have either x equals something or you'll have y equals something. Once you have that value, you want to substitute the value into from step 3 into either of the original equations. Either of the original equations will work. Usually, again, there is an easier one to use, but it's just your preference. And finally, because we do typically have systems of equations with the variables x and y, you finally write your answer as an ordered pair. Ordered, and then on the second blank, pair. And in case you're unfamiliar with the word ordered pair, that just means x comma y. So that's what we're talking about here. You need, I guess I'll put it out here. You need x comma y as your final answer. So I'm going to try and keep my my steps on the top, and I'm going to use my drawing tool now to solve the system by substitution. So step 1 was to solve one of the equations for a variable. Well, in this equation, in the first equation, we have y equals 2, and it's already solved for. We just have y equals 2. We want to substitute what y equals into the other equation. So y equals 2, I'm going to circle the 2, and I'm going to put an arrow for the variable y because that's what y equals. So that's where I'm going to substitute. So I have x plus 3 times not y, but now 2 equals 14. And I'm going to solve for x. So I need to multiply 3 times 2. 3 times 2 is 6. And I need to remove the constant. So I have x equals 14 minus 6, which is 8. So I have an x equals 2. I have a y equals 2 and x equals 8. And I can write my answer as an ordered pair, x comma y. So 8 comma 2. Now typically, you would check your work. And I realize that my handwriting is crummy. I'm sorry, I'm trying to write this on a different tablet. So I do want to check my work and make sure that everything is correct. I don't have to substitute any values into the first equation because it's just y equals 2. But in the second equation, I do want to make sure that my 8 for x and my 2 for y, when substituted, do in fact give me a resulting value of 14. So 8 plus 3 times 2 is 6. That does actually equal 14. So that's good. That's what we want. So I'm going to move on to the next example. Okay. Example number 2. Step 1 is to solve one equation for a variable. Well, I notice that in both of these equations, both have y equals and then an expression. So in both equations, y is already solved for. It's isolated, it's by itself, it's solved for. So I move on to step 2. Substitute the expression that y equals into the other equation of the system. So I'm going to go ahead and circle what y equals. And I'm going to draw an arrow to where I put it. So if it equals y, then I substitute it for y. So I have 6x minus 4, there we go, equals negative 2x plus 28. Let me go ahead and fix this. I feel like this definitely does not look like minus 4, huh? There we go. Okay, so I'm going to move my variables to the same side of the equation. So I'm going to move my negative 2x by adding 2x. I have 8x minus 4 equals 28. I'm going to move my constant to the other side. I have 8x equals 32. And I'm not going to show the work because I'm running out of space, but if I divide both sides by 8, I get x equals 4. So there's one value in my ordered pair. My next step, because I did step 3, I solved for x. My next step is to substitute the value from step 3, so x equals 4, into either of the original equations. So go back and look at the original equations. I noticed that the first equation looks a little bit nicer than the second equation. So I'm going to go ahead and put 4 in place of x there. So I have y equals 6 times x, but x is now 4, minus 4. 6 times 4 is 24, and if I subtract 4 from that, I get 20. So my x value should be 4. My y value should be 20. And that is my ordered pair. Now, again, it is a good idea for me to check. So I'm going to go ahead and check my work. And I need to take 4 for x and a y value of 20, and I need to substitute them into both equations to make sure that they work out. So in the first equation, we have y equals, so 20 equals 6 times x, which is 4, minus 4. Well, 6 times 4 is 24. 24 minus 4 is 20. So this works. In the second equation, we have y equals, so 20 equals negative 2 times x, which is 4, plus 28. Well, negative 2 times 4 is negative 8, and negative 8 plus 28 is kind of like 28 minus 8, and that is, in fact, 20. So that works. Our solution is 4, 20. Moving right along, if I go to example 3, there we go. Step number 1 is to solve one equation for a variable. Out of both of those equations, I see that the variable y in the first equation doesn't have a coefficient visible. Its coefficient is an invisible 1. So I'm going to choose the first equation, and I'm going to choose y to solve for. So 2x plus y equals 8. If I want to solve for y and isolate it, I'm going to move the 2x term to the other side. And I have y equals negative 2x plus 8. If you were thinking 8 minus 2x, that is definitely not wrong. I'm just in the habit of putting my lines in slope-intercept form. So now that I have y solved for, I'm going to take what it equals, and I'm going to substitute it into the y for the second equation. So it's going to go right there. So I have 6 times x plus 3 times y. What is y now? It's the expression negative 2x plus 8. And it's supposed to equal, up here, negative 15. Ooh. All right. From Algebra 1, you should remember that when you have a 3 outside of parentheses, you distribute it to every term inside using multiplication. The 6x does not get distributed. So we have 6x. We have 3 times negative 2x, that's negative 6x. And we have 3 times 8, that's a positive 24. And that should still equal negative 15. Now, what happens with my x terms? I have 6x minus 6x. If I combine those together and I had 6 and then I subtract 6, well, I have no more x's. I have 0x. And the only thing remaining in my equation is that 24 is equal to negative 15. And even if you are not in Algebra 2 or even Algebra 1, you would know that 24 does not equal negative 15. So there's no x value that we could use that will make this equation correct, which means our solution is what? There isn't one. We have no solution for this system of equations. Now recall from yesterday that whenever you were graphing to solve systems of equations, a situation with no solution meant that your 2 lines did not do what? They did not intersect. Those 2 lines did not intersect. And so that's the situation that we have here. If we were to graph those 2 lines, then we would have 2 lines that do not intersect. They would be parallel to each other. Finally, we have example 4. And example 4 has a fraction in it, but it shouldn't be a big deal. So I'm going to help walk you through it, but I'm not going to do the entire thing like I have the other ones. I'm going to give you time to try it out. So step 1 is to solve one equation for a variable. Look at those 2 equations and determine which one and which variable it would be easiest to solve for. I'll give you a second to think. It would probably be easiest to solve in the first equation for x. That equation has no fraction, and the x variable has a coefficient of 1, so it's not going to be too difficult to solve for x. So we have x plus 2y equals 8. If I want to isolate x, that means I want to do inverse operations to move that second term. And I have x equals negative 2y plus 8. So step 1 solved, done. Step 2. What is step 2? What do I do with what I've found? I want to take what x equals and I want to substitute it where it goes. If it equals x, then it goes in place of x. So I'll give you a moment to write down your new equation with x substituted, and then you can check your equation with mine. So pause the video and write your new equation. So your new equation should be 1/2 times x, but x is negative 2y plus 8 minus y equals 18. Again, from Algebra 1, remember that anything outside of parentheses but touching parentheses should be distributed to each term inside parentheses using multiplication. So think about half of negative 2y and half of 8. I'll let you write your new equation after distributing. So half of negative 2y is negative 1y. Half of a positive 8 is a positive 4. I still have minus y, and that still should equal 18. So I'm going to give you a moment to continue and finish solving for y in this equation. So pause your video and try to continue.